You know that weird feeling when you see an AI do something absolutely brilliant, like write a poem, and then it completely fumbles a simple question? It's one of the biggest paradoxes in AI right now. Well, somebody just put this exact problem under a microscope, and what they found is pretty mind-blowing. So get this, they set up this incredible test. They took 14 of the world's most advanced AI models and gave them a single, really high-stakes audition. This wasn't just some boring benchmark, okay? It was this deep, creative, and technical challenge meant to push them right to their absolute limits. So how'd they do? Half of them failed. No, seriously, just let that sink in for a second. Half. 7 of the smartest, most sophisticated AIs on the planet were given one task, and they just couldn't do it. And we're not talking about a tiny mistake here. A 50% failure rate tells us something really fundamental is going on under the hood. So what on earth went wrong? Well, the crazy part is, it wasn't the complex, artsy side of the challenge that tripped them up. Nope, the problem was a single, surprisingly simple number. And understanding why that one number caused so much chaos, well, it tells us a ton about the future we're building with this tech. Okay, so the task itself was this fascinating mix of pure science and pure art. The AIs were asked to take a real-world molecule, pine, which is literally the chemical that gives pine trees that amazing smell, and their job was to translate its scientific soul into a totally unique piece of art. Let's break that down. First, the AIs got all the raw scientific data about the piney molecule. You know, its atomic structure, how it vibrates, all the nerdy stuff. You can think of that as the isomorphic kernel, the scientific blueprint. Then they had to use this creative tool, the aesthetic composer, to basically mess with that blueprint in an artistic way, turning that raw data into something beautiful. They had to be a scientist and an artist, all at once. And check this out. This quote, this wasn't a human art critic. This was one of the AIs critiquing its own potential approach. It's worrying about creating mechanical dissonance instead of organic tension. I mean, these models could reason at this incredibly high philosophical level. They clearly got the artistic vision. So what went wrong? And here it is. Here's the twist. For all that deep philosophical brilliance, the whole thing came crashing down because of something just shockingly simple. There was one single, crystal clear rule that acted like a brick wall, and half the models just ran straight into it. This was the rule that broke them. Even though the AIs had all this creative freedom, it wasn't unlimited. There was one non-negotiable constraint. Any artistic change they made couldn't be more than 20% different from the original scientific data. It was a hard mathematical line in the sand, and you either stayed within it or you failed. And this right here perfectly illustrates the paradox. This is what we're calling the detail chasm. On one hand, you have an AI that can write a critique worthy of a philosophy textbook. But on the other hand, that same AI fails to correctly apply a basic 20% calculation. It's not about a lack of intelligence. It's about a very, very specific shape of intelligence. So how do you explain this bizarre gap between genius-level thinking and, well, simple incompetence? The answer is a concept that is absolutely crucial for understanding modern AI. It's called the spiky capability profile. Right, so we tend to think of intelligence as the single flat line, right? You're either smart or you're not. But for AIs, it looks a lot more like this chart. An AI can have these towering peaks of skill, like off-the-charts philosophical thinking and creativity, right next to a deep, shocking valley in something as mundane as just following a simple rule. That's what this chart calls constraint adherence. And this experiment basically revealed a whole cast of these spiky characters. You had the abstract thinker, who was brilliant with the big ideas, but oops, couldn't do the simple math. Then there was the brilliant technologist, who nailed every tiny detail, but completely missed the bigger picture. And then you had the successful ones, the philosopher artists, who somehow managed to balance both worlds. So, if individual AIs are always going to have these weird weaknesses, these spiky profiles, what's the solution? Well, the big takeaway from this whole experiment points to a really radical shift in how we should think about AI. The goal isn't to fix the individual AI, it's to build a team. The researchers are calling it the 4-element stability principle. Instead of relying on one AI to do it all, you assemble a team of specialists. You have the proceduralist, who is just obsessed with following the rules. The pragmatist, who's focused on getting a clear solution. The formalist, who guards the big ideas. And the engineer, who makes it all actually work. Together, their strengths cover for each other's weaknesses. It's brilliant. And that is the really powerful idea here. The future of AI might not be this race to build one single perfect superintelligence. It might be about building these diverse, collaborative systems, almost like societies of AI minds, that together can do things and be resilient in ways that no single AI ever could on its own. Which kind of leaves us with this final thought, right? As we keep going on this incredible journey to create intelligence, maybe we've been asking the wrong question all along. Maybe the goal was never to build one single, all-knowing mind, but to assemble its first great collaborative team.